Now let me introduce this morning's keynote, Fady Saad. Fady is the co-founder and vice president of strategic partnerships of MassRobotics, an innovation hub, collaborative workspace, and laboratory for robotics startups, located in Boston's Seaport Innovation District. He's also a systems design and management fellow at MIT, where he focuses on designing and modeling startups as adaptive, complex systems and understanding the effects of entrepreneurship ecosystems of these startups' viability. Fady's leadership is at the forefront of lean, robotics, and AI, changing the way we work and do work. His topic today, the new era of lean, robotics, and AI, speaks directly to the theme of this year's conference, 21st Century Lean. Let's welcome him to the virtual podium.
Thank you, Bruce, and it's a real pleasure to be with you today, all. And I'm based here in Boston, Massachusetts, and it's amazing to see this international crowd. I'm not a stranger to lean. Back in the 90s, when I studied mechanical engineering at the American University in Cairo, I specialized in industrial engineering, and this was the first time I got exposed to just-in-time and total quality management and continuous improvement and all these amazing methodologies. And in fact, my first ever internship was at BMW Service Center. And I inspected and maintained cars myself, and I got exposed to how lean is actually implemented in practice. And my second ever internship was at Unilever, as you know, large FMCG player. And I was working at their factory in Egypt, and my mandate was actually deploying total productive maintenance to the entire factory and localizing the material, delivering trainings to more than 20 production line workers and technicians. So I have lived lean, total quality management, and when my first job ever was at Siemens Communication Services Division, and again I was tasked to do a major process re-engineering for their logistics and supply chain department. And then the division was going through an ISO certification, and they were adopting total quality management. So I found myself in the middle of all of that. So I have lived lean and all the amazing philosophy around it for a long time. And after that, I jumped to strategy, business development, and led the merger between Siemens and Nokia Networks in North Africa. And actually, I was very passionate about building and scaling companies, as Bruce mentioned, and I got exposed to system thinking, which for me was another kind of evolution of all the lean methodologies that I have learned, but applied more to organizations and companies. So I'm very pleased to be with you today. And I just want to say it's an amazing time to be in robotics. So after I finished my graduate studies at MIT, I got heavily involved into robotics and was working with one of the key robotics company in the city. And the company was developing cutting-edge robotics technology, whether it's in machine vision, so giving robots or machines ability to see things and recognize things around it, or manipulation, so arms and with high dexterity, autonomous navigation platforms. So these are robots that can navigate on itself. I believe yesterday you had a very interesting presentation about using a mobile platform with an arm in a kind of dentist supplies manufacturer. I forgot the name, but I watched the presentation. So all these kind of cutting edge technologies, and this is when I got heavily involved into robotics. So I have to say it's an amazing time to be in robotics now. Obviously, As you know, in the past, everyone was kind of scared about robotics, especially manufacturing, that robots will take away jobs. And we don't hear this anymore. The only thing we hear now is robots will save lives, because probably for the first time in history, we have seen a scenario where you don't want humans to be out there exposed to this nasty virus. You want robots on manufacturing facilities, logistics, disinfecting hospitals and hotels and offices, schools. You want them to do deliveries. So it's quite an interesting time, and we definitely have seen a spike in terms of robotics technologies interest and adoption across the board. So my talk today has three main parts. The first one is what's happening. So what's happening in robotics and AI and all related technologies. And the second part is how this will change the way we think about lean and the way we think about our approaches and methodologies towards lean. And I will conclude by how we can prepare for this revolution, which is not coming, it's already happening. Robotics and AI is already penetrating many sectors, including manufacturing. So how we can better prepare as lean practitioners and manufacturing leaders for what's happening. And I just want to clarify that throughout my presentation, because I get this a lot, like when I mention robotics, I don't mean humanoids. I don't mean robots that look like humans. This is totally out of my scope. When I say robotics, I mean either a full stack hardware and software platform, like autonomous vehicles, like collaborative robots, like autonomous mobile robots or automated guided vehicles, drones, or pure enabling software technologies like AI, machine learning, cloud robotics. And it could mean also individual components, so sensors, processors, interfaces, obviously IoT, kind of a larger term to cover many of these things. So this is what I mean. Every time you hear me saying robotics and AI, this is what I mean. Try to take away the Hollywood picture of humanoids and Terminator-like robots. So what has been happening? What has been happening is we have been seeing, probably for the first time, robots being widely adopted, and heavy, bulky, risky, expensive robots like the one that you see on the top left corner. Those robots are getting out of the cage. As many of you know, those were dangerous robots and usually want to have humans separated from them. But this picture is actually a picture from a local company here called Robotics. And Robotics, they have a very innovative solution, which basically give eyes and perception to these bulky robots. So now these robots can see humans when they enter their cell. And the way they manage to do that, if you notice at the top, there are those kind of black cameras. If you come closer, you'll see it. But those are cameras that basically see the whole cell and then feed this image into the robot so that the robots will know where exactly is a human. And depending on the proximity of the human, the robot could slow down further, or totally stop when the human is too close. And this is a very interesting solution because it doesn't require manufacturers to replace the huge army of industrial robots they have, but rather upgrade them with this new technology. So it's opening up lots of applications where you can actually have humans and robots working together. And I think this is in general a common theme across many of the technologies that we have seen being developed now. When you look at the picture beside this on the top right, you see this. This is a universal robot arm, which probably many of you have seen yesterday in the collaborative robot presentation. But the interesting thing is this gentleman is using the arm to do an inspection. So this arm has a camera, and it can go over the piece and basically do a quick inspection, visual inspection of this unit. On this picture, what you see, this is an autonomous mobile robot, or AMR. And the old generation of these robots were called AGVs. I'm sure that many of you are familiar with AGVs, so autonomous guided vehicle. And basically, those were vehicles that would follow lines on the floor, laser beacons, or magnetic tapes. They had some sort of something to guide its movement. But the new generation that we see now, these are robots that actually do not need any of that. They have sensors, they have cameras, some of them have laser scanning or LiDARs, and they basically can see humans, can see objects, obstacles, and they have an internal map of the whole facility, and they basically can navigate on their own. They don't need any guidance. They don't need a hard programmed map or path. They basically can navigate on their own. Obviously, they have a target, like deliver this item from point A to B, but then the robot will figure out the optimal way to do that. So this is another group of robots that we have seen huge advances. And obviously, this technology is widely used in logistics, but also we are seeing more and more deployments in manufacturing settings. This picture you see, again, this is a collaborative robot, and I mean, you will see lots of universal robot arms because universal robot is the dominant player in collaborative robots. And the company got acquired a few years back by Teradyne, a Massachusetts-based company, and became part of this company. But they are the dominant player in the space. And you see, now, this is a small robot. It's called collaborative because it's safe to be around it. It has torque sensors, so if it's moving and then it feel any resistance, whether it's touch a human or something, it will immediately stop. And it's also lightweight, so the damage is not that significant if it hits something or someone. The other thing is they are relatively cheap. Much easier to program. And what these collaborative robots did, they open a whole new segment of automation that was not possible before, because as you know, the large, bulky, expensive robots, you had a certain setting in order to justify the return on the investment. But with these robots now, you can actually automate much larger possibilities of tasks that you have. So for example, in this picture, you see the robot is actually tending a machine. So this is also a whole new revolution in terms of the way we use robots and automation in our manufacturing flow. The last picture here, this is advances in gripping technology. So you see the end effector of the arm. These are called grippers or end effectors, and basically these kind of technologies developed dramatically over the last few years with intelligence. So now with a depth camera mounted at the end of the arm, the gripper and obviously the whole system can basically identify items. So it can pick certain items. It can classify, it can separate things, it can even check for quality, it can pick the defective items, all of that. Basically, you are enabling the gripper to identify and see things. Not only that, but we have seen developments on the variety of objects that these grippers can handle. So a local company here called Soft Robotics, they developed this pneumatic gripper that allow it to basically grip different shapes and also things that typically were hard to grip with a mechanical gripper. Things like food, things like bakery, things like eggs, things that you could crush if you don't have the right strength. But with these pneumatic controlled grippers, you can actually handle a variety of options with high mix too. So this is another thing that we are seeing advances in the perception of the robots. We are seeing advances in the mobility of the robots. We're seeing advances in the dexterity and manipulation of the robots, and then we're seeing advances in the actual grip. Not only that, but as you can see in this picture, so this is a Six River robot. So this is another local company that got acquired last year by the Canadian e-commerce giant Shopify. So Six River is developing this robot, and they basically changed the whole process of order fulfilling. So now the robot knows where are the items, and a worker will follow the robot to do the pick and place, because it's a very complicated technological task. So rather than spending the money and trying to justify this, just focus on the transport and the kind of localization of the items. In this picture, you see, again, machine vision technologies for an inspection of electronics. So again, lots of advances, not necessarily a complete platform or a full stack. Again, as I said, this is just a sensor. It's a component that we have seen lots of advances in. This picture is actually a picture from a company called Humatics. And Humatics is relatively a small company. They started a few years back, and a spin-off from MIT. The founder is an MIT professor. But they are the pioneers in what's called micro-location sensors. So these are tiny, small, cheap sensors that can reach to a millimeter accuracy. And rather than having these sensors on the robot, you can spread these sensors in the infrastructure. So for example, in this picture, you see the manufacturing floor. So you can have these sensors across the whole factory. And then the other assets that you have, whether these are robots or industrial IoT systems or whatever, can actually communicate to these sensors to localize, to get data about the whole facility. But it's a revolutionary concept in terms of using high accuracy sensors that you can have in all of the facility. And again, you could say that this is more of an IoT, but I'll speak about that is I don't buy into the marketing terms of AI and IoT and industrial IoT and all of that. I think what we are heading towards, and this is the very heart of Industry 4.0, which was a methodology and approach that kind of structured and promoted from German manufacturers. I think the heart of Industry 4.0 and all of these technologies is what's called smart manufacturing systems. And I think this is what we are heading towards. I don't think that anyone care about what are the subcomponents. I mean, I have here my smartphone. Frankly speaking, I don't care about the technologies that get into it. I don't care about all the sensors. When I buy it, I don't ask about like how many sensors you have there. I don't care about any of that. What we care about is the utility. We care about the service that we are getting out of that. And I think we all should think in these terms, that all of these technologies will get blended together into smart manufacturing systems. And why do we need smart manufacturing systems? I think this is what's happening in manufacturing now. There is higher demand for highly customized manufacturing systems, because this is the nature of today. The consumer, they want highly customized systems, highly customized products. So an interesting term is mass production in quantities of one. When you go and buy a pair of shoes, you want those to be customized for your particular use and the shape of your feet. You don't want to just buy any generic pair of shoes. So I think this is where we are heading to, and the hierarchy that you see, this is the hierarchy of Industry 4.0. And the foundation is the smart connectivity level, which is all the smart sensors, IoT, all of that will fit here. And then once you have these sensors, you collect the data, and then you convert this data into information using data analytics. And then once you have that, you create a cyber level, which is another term that I'm sure you heard about, which is the digital twin. So you create a digital twin for your operation so that you can run simulation, you can see things, you can predict things, what will happen, mean time between failure, kind of plan your preventive maintenance and all of that. And the last, not actually the last, but the next level is the cognition level, which is, this is where AI and decision-making fits. So how you can look at all of these simulations and scenarios and actually make a decision what need to be done. And finally, the configuration level, I think this is where hardcore robotics will fit, which is self-adjust, self-configure, self-optimize assets. So these robots and arms and autonomous mobile robots, based on what the AI is telling them, they will self-configure and self-adjust to cope with the demand they have. So this is what I see happening, and one of the things that kind of inspired us to create MassRobotics was all of these kind of advances. So so we started MassRobotics back in 2015, and very quickly we grew to become the largest hub for robotics innovation and robotics commercialization in the US. The size of the cluster that we have been leading is around 350 robotics companies, and we have been hosting more than 50 resident startups, all kind of creating innovative technologies. And a core part of our model is to have corporate partners. So companies like Amazon Robotics, iRobot, but also Mitsubishi Electric, Analog Devices, FedEx, Honda, GM, Lockheed Martin. Those are all companies that we speak with on daily basis, listen to their needs and what they are looking to get out of robotics and AI. Just to kind of, this is complete what's going on, that there's a huge revolution in terms of scaling robotic startups. So what will change? So I think two things wouldn't change before I jump into the things that will change. Two things wouldn't change, and I think you would all agree with me. The lean principles wouldn't change. I mean, by the very definition of principles, they shouldn't change. And I think the process also, the plan, do, check, act, the continuous improvement process wouldn't change. I think, on the contrary, these are the fundamentals for any automation and adoption of new technology. Is you have to get this right first. Otherwise, you'll be wasting money and time in trying to automate something that is not yet optimized. So I think those two things wouldn't change. However, I think that 5 things will change. And those 5 things that will change has to do with the amount of data that we will have access to. So the deployment of smart sensors and IoT will give us a huge amount of data, and not only amount, but complex data that we need to figure out what are we going to do with that. So this is definitely one thing that will change. So data analytics platforms, artificial intelligence, machine learning, all of that is not a luxury, wouldn't become a luxury. It's a must. It goes hand in hand with deploying of smart sensors, because what are you going to do with the data? You need a complex system to handle that. And as Ashby's law said, only complexity can absorb complexity. So we have to have AI and machine learning in order to handle this vast amount and complex amount of data. The second thing is the speed of the process. So the speed will also change, because now in the past we used to have like collect data, have reports, have sessions, and kind of team meetings and discuss what this means and all of that. Now we will be living in an age where we have a near real-time data. You have these sensors giving real-time data, and you have the cyber kind of level, the digital twin, again, simulating things almost near real-time. So the speed also will change, right? The third thing is the agents of the process will evolve. The people who are driving the process, impacting the process of lean will change. So we need to get comfortable with the idea that AI algorithms and machine learning will learn lean. They have to, right? So they will learn lean, and they will be contributing to your teams. And I think, as I mentioned, the human-robot augmentation theme is here to last. Don't think of AI. I don't think that AI will replace what you are doing, because we are not yet there. We are far out from having an AI doing complete kind of lean projects and continuous improvement. But however, they will be part of the team. It will be another data point informing what should be done. And we should embrace that those will be part of the process. The fourth thing is the solution and the implementation approaches that we will adapt will dramatically change. Because now we'll be using robotics platforms and AMRs and AI. So this is, consider it as another tool in your toolbox that you will utilize in order to improve processes and achieve a continuous improvement till perfection, basically. And the last thing is this will eventually reduce waste in the process. So lots of waste will be reduced, because, I mean, as you have seen, AMRs now reduce a lot of waste in terms of transport. And I think the presentation you listened to about the mobile manipulation had a very nice business case around that. We have seen this also in hospitals. We have seen this in logistics platforms. So the waste will dramatically reduce. And this eventually will free up lots of human resources that will do more higher value and value add activities. However, this is all subject to the speed of adoption. So as you are familiar, I mean, the unions, the regulators' perspectives, all of this could slow down or speed up the adoption of these technologies. The technology is here, and it needs people like you to understand it, embrace it, and kind of integrate it into the day-to-day activities. So, what does this mean for us? How to better prepare? I think few things that we need to think about, mainly three things. The first one is continuous learning and reskilling. I believe that, I mean, although I don't practice lean, but deep inside, lean is my way of living. It's a lifestyle. It's a lifestyle of always optimizing your activities, eliminating waste in your time, in your resources, and in your relations, and everything. So, and part of that is making sure that you are up to date about what's going on around you. We are very fortunate to have this wealth of knowledge at our fingertips. There's tons of material online about robotics, AI, all of these technologies. On our website, on MassRobotics website, massrobotics.org, we have an online calendar of events that are happening. You can subscribe to our newsletter. There is wealth of activities happening that can open up the door for you to learn more about robotics and AI. There are other leading organizations in the space, also very close friends of MassRobotics and partners. So the Robot Report, the Advanced Robotics Manufacturing Institute, A3, the Advanced Automation Association, and the Robotics Industry Association. All of these organizations, they have lots of information, lots of resources, events, and I highly encourage all of you to get engaged to learn more. And the other thing on the continuous learning and reskilling is get engaged with the innovation ecosystems and the startups, because this will give you a good pulse of what's being developed, what are the upcoming technologies. So you are better prepared and not surprised by a new piece of technology that get deployed. So this is for the first one. The second thing, and I have seen this many times when I was practicing lean and total quality management, is sometimes we get into this trap of being linear thinkers, of kind of cause and effect only. We see only one side of the equation. And I think in today's world, we need to be non-linear thinkers or system thinkers. And this helped me a lot when I studied systems and complex systems. It didn't kind of conflict with my understanding of lean and continuous improvement. And I do believe the heart of lean and continuous improvement is a closed loop system. But sometimes we forget that. So we need to remember that companies and manufacturing facilities are large interconnected systems and not independent separate processes or departments. There is lots of influence, lots of things going on. So I highly encourage all of you to think in terms of systems. I hope you will find it, as I found it, very helpful in terms of implementing and deploying lean methodologies. And the future, heading towards us is all about complex systems. So this would be my second kind of recommendation. My third one and last one is robotics and AI smart systems, whether it's manufacturing or logistics systems, are already here, as I mentioned. So please do not resist it. Lead the change. The best way to adapt to change is to lead it. And I true believer in that. And one of my favorite quotes is a Darwin quote that say that it's not the strongest nor the most intelligent that survive, but the most capable of adapting to change. And I think we are at, as you can see on this picture, we are at this kind of zone of disruption. Disruption is already happening. And then the zone of adoption, some industries already in this zone of fuzzy adoption. So we are somewhere here. I think we need to embrace that, and we need to get into robotics and AI, and rather than resist the deployment or mock what the technology can provide to us, think collaboratively with the robotics and AI community how we can better leverage and utilize these technologies for our manufacturing facilities. So these are my remarks. What's happening in robotics, how this will change the way we think about lean, and how we can better prepare. But one last thought that I will leave you with is, looking at the world today and the amount of waste we have, waste that created problems like climate change and poverty and pandemics and The pandemic was a wake-up call that despite all the knowledge we have and all the technologies, we were very vulnerable, and we were totally unprepared. I think that the world needs lean, and robotics and AI is not the enemy. It's just another technology, and it's really up to us to use it for the good of humanity, or not to use it. And I think we all agree that we want to create a better future for our children and grandchildren. So I think joining forces between lean and the robotics and AI community will be a very powerful driving force in our factories, in our supply chain, that I think will definitely create a better future for all of us. Thank you all for listening, and it has been a real pleasure to be with you today. And I think we have a few minutes for some questions. So Bruce, back to you.
So thank you, Fady. That was really great. It was great. So many great examples and wonderful connection to lean thinking. I never realized all that background you had before you got into your current gig. That's really great.
I kept it as a surprise, Bruce.
So we've got quite a few questions here, and let me get to them. Some specific, some general. Here's one. What is the current? This is from Tom. What's the current state of safety as far as preventing robots from either injuring people or causing defects in production?
Yeah. Great question. As you can imagine, safety and security are probably two of the most important things that roboticists keep in mind. And it's no secret that it only takes one accident to bring the whole industry 10 years back. And we have seen this happening. So my short answer is there have been lots of advances around safety. Some of the organizations I mentioned, actually, they're working on safety standards. There are already some safety standards for autonomous mobile robots and even collaborative robots and others. The advances in sensors technologies are also helping a lot. So Panasonic is one of our corporate partners in MassRobotics, and last year we ran a whole program around using LiDARs, laser scanning sensors, for safety around collaborative robots and industrial robots. And we have seen this over and over with analog devices, with Mitsubishi Electric. So safety is definitely a common theme.
Thanks, Fady. So actually picking up on that theme, you'd mentioned collaborative robotics. Questions from Elizabeth. What recommendations do you have for manufacturing frontline workers to support them in adapting?
This is an interesting one. I think it's the same message. I mean, robotics and AI, just one piece of interesting information. Can you think of what's the largest market for robotics? It's China. 40% of all robots that will be deployed 2025 will be in China. So China realized that they cannot compete anymore on just cheap labor cost because of the economical activity they generated more wealth, and now they cannot keep the labor cost the same level because basically labor are demanding more wages. So they cannot maintain that, and they know in order to stay competitive they need to adopt robotics technologies. So the whole narrative that robots will take away jobs. Look at Amazon. I mean, Amazon is probably one of the largest users, e-commerce companies using robotics technologies. I mean, all of their warehouses using Kiva systems, which is an automated guided vehicle system. But this has been their secret weapon. This is how they managed to do like a second day delivery or 2 days delivery, because they have robots running around. And look at Amazon. I mean, just the other day, yesterday, I've been reading that Amazon is buying more and more spaces in Massachusetts. One of the movie theaters is shutting down, and it's huge footprint. And Amazon is going to buy this. And there are also negotiations with malls, malls that are not doing well during the pandemic, so they will sell these lands to Amazon. So they are expanding and they are creating jobs. So again, not using robots and AI, resisting robots and AI is not the way to go. I mean, from a larger perspective, we could lose all of our manufacturing capabilities and competitiveness as a country, and in any country actually, not only the US. So it's something that we all have to embrace. Yes, some people will be impacted by robotics. Yes, I'm not saying that. I mean, key justification for the ROI, not only the speed, the efficiency, productivity, throughput, and all of that. Yes, it will eliminate some jobs, but it will also create other jobs. So the real question, and this has been a key dialogue within the robotics and AI community, is the whole topic around workforce development or workforce reskilling. And this was one of my first recommendation, is we need to, rather than resist what's happening, we need to better prepare and add new skills on how to kind of use robotics. And I personally found it very helpful when I found myself in many situations in many companies and speaking with investors or advising a startup company. When I know the lean methodologies and I know the lean principles, but I have another functional expertise, whether it's business development or strategy or product development, and using the methodology in order to do my job better and more efficient. So I think anyone in manufacturing now, they should know enough and a good amount about robotics and AI, and in a sense become semi-experts in robotics and AI. I think it's paramount.
So thank you, Fady. Here's a kind of a different question from Mark. He says, how can we ensure that AI and robotics don't just hide waste or add to it rather than helping us to actually remove waste?
Yeah. This is a great question. And this is actually something that I have been advocating on your behalf to the robotics community, which is you cannot automate what's not yet optimized, in my opinion. So and as many of you know, like if you don't, when I was doing process reengineering, you need to re-engineer the process before you think about automation. And in my opinion, this is the way to avoid just introducing automation that not generating any benefit or even maybe adding more waste to the whole process. So I think the right order is you have to think about the process first. You have to optimize the process and then think which parts need to be optimized. And I really like the exercise that was presented yesterday. I forgot the name of the company, but when you look, they analyzed all the waste in terms of transport, and they consciously selected the longer distance optimization. They didn't automate the rest because it didn't justify the ROI. They just focus on the one that has a long distance, that like, why have a human do this transport? Let's have the robot fill this kind of leg. And I think this is what we need to do. And again, another reason for lean practitioners to get heavily involved into robotics. Frankly speaking, I have always kind of advised my kind of connections and startups in MassRobotics and even startups that reach out to me that you need to look at the application and you need to make sure that it's robotics is the right answer, because frankly speaking, robotics is not always the right approach. And sometimes we over-engineer, we over-design robotic systems, while the problem or the application can be solved with a much simpler technology. And we have seen this in terms of the market. I mean, the market is ruthless. So if you don't have the right technology, the market will just kill you. And if you have the right solution, the market will embrace it. And that's why we have companies that succeed and we have companies that fail. So again, I think it's this joint forces between people who have the knowledge about lean and continuous improvement and optimizing processes and the people who know the technology, what the technology is capable of.